Today I will talk about case-based reasoning. It is part of my series of lectures on machine learning. This is my lecture outline. First I will give introduction, then I'll talk about knowledge in case-based reasoning. Then I will give advantages and disadvantages of case-based reasoning. Then I'll talk about steps of case-based reasoning. Then I'll talk about mathematics behind it. And finally, I give an example with Python code. Machine learning is a subdomain of artificial intelligence whose main aim is to develop models that allow the system to make a decision without human intervention. It involves designing systems that are able to learn from situations and improve further for efficient problem solving and decision making. In our day to day life, we all learn from our past experiences to move forward and handle situations that life throws at us. Case based learning is a similar approach in which we address new problems by learning from past experiences. So, this is about case based learning. In case based reasoning, a new problem is solved by adapting solutions that were also useful in the past. So, we have a repository of problem with solutions of the past. Therefore, it is also referred to as experience based approach or intelligent problem solving method. Then knowledge in case based reasoning, vocabulary. Vocabulary involves the process of determining information about attributes and parameters required for the selection of features that are used for determining cases. Then similarity measures. Similarity measures mean analyzing similarities between cases and selecting efficient method to deal with the problem. To choose the most efficient similar measure, we must have a complete understanding of the actual domain problem. And most commonly used similarity measure is the distance between feature vectors. Adaptation knowledge. Adaptation knowledge means adapting the information needed to evaluate multiple stages in the CBR cycle. It tells how difference in problems affect the solution. It involves guiding a process to improve a solution and select those which fit better to the needs and constraints of the given problem. Then cases. Cases consist of information about the solved problem. They are the representation of stored knowledge of past experiences and are fundamental part of the CBR cycle. Their content is determined on the basis of selected vocabulary. Then advantages and disadvantages. CBR helps in avoiding past mistakes because we have a repository of past problems and their solutions. CBR is efficient in adapting to new problems by making use of previous cases. So we can retrieve previous cases and we can adapt those according to new problems. CBR considers small details, features, and information relevant to the problem for effective decision making. Case retention in CBR helps in expanding knowledge and improving the system. This is training part of machine learning algorithms. Then disadvantages, CBR can be time consuming as it involves various stages of retrieving similar cases and arriving at the best solution. CBR is a resource intensive process. It requires more computational power. Scalability issues are there. With the increase in case base, the time needed for retrieving and adapting the case also increases, affecting the overall efficiency. CBR may give out incorrect solutions if the cases are not represented correctly. So these are few disadvantages. Then steps. So these are the steps: retrieve, reuse, reasoning results, revise, and retain. Retrieve. Here given a new problem. Cases that are similar to the given problem are retrieved from past archive. A case is usually associated with the problem description, used for matching it to a new problem and its corresponding solution. So this is the case archive where we have problem description and their solutions. Then after the initial retrieval step, the previous solutions are reused for the problem in hand. Reasoning results. It refers to applying the filtered information and solutions by analyzing previous similar cases to the present problem. In this step, we generally use algorithms and heuristics to narrow down to a solution. Revise. Oftentimes, however, the retrieved solution cannot be directly used, and hence the solution need to be revised. And these revised solutions with their problem are again stored in the archive for future use. Retained. Lastly, if the revised solution is useful for solving the given problem, they are retained in memory so that they can be used in the future. So this image I have taken from internet. So this illustrates various steps. So this is we have a current problem. Then we retrieve solution to the current problem based on the archive of cases, that is problem and their solutions of past. Then if we identify useful case, we reuse it, and that is the solution to the current problem. If need arises, we revise it and then we retain to the archive. Then mathematical basis, as we have seen, the similarity measure is usually the distance measure between feature vectors. So most commonly used distance is Euclidean distance. We can parameterize each entity. Then the similarity between two entities is calculated by a simple inner product between the normalized embeddings. So this is a definition of Euclidean distance, but there are many other distances. So these are various distances which can be used, and the important one are Euclidean distance, standardized Euclidean distance, squared Euclidean distance. Then Mahalanobis distance, this is the formula for that. Then Hamming distance, then cosine distance, this is the formula for cosine distance. Some of the distance measures, they are affected by high dimensions of the feature vector. So we need to understand in which situation we should use which distance measure. This I have taken from this website. This is the pictorial representation of various commonly used distances. This is the cosine distance. It is the angle between two vectors. This is the squared Euclidean distance. It is also known as L2 norm. This is Manhattan distance. This I have taken from this site, again graphical illustration of various distances. This is Euclidean distance, this is Manhattan distance, this is cosine distance, this is Hamming distance. It matches actually each element of the feature vector with other vector. Then these are other distance measures. CBR may involve the written material or documents. Lot of written words may be there. So how to deal with words or how to deal with language data. So this is the summary actually. I have a separate lecture on using the words or language in machine learning, that is natural language programming or processing. I have a separate lecture for that. So these are the actually various methods which are involved in the processing of words or language. These include lowercasing, removal of punctuation marks, removal of stop words, stemming, lemmatization, tokenization, TF-ID vectorization, and then training a machine learning model. Then finally, Python code with an example. So these are the libraries. First one is NumPy for array and mathematics, then Pandas for data frame. Then I have used the modified iris data for illustrating the use of case-based reasoning. Then SciPy is to calculate the distance between the feature vectors to retrieve our case. So this is my modified data. I have modified iris data. The modification is just that I have labeled the target variable with the text information as species name rather than coding as 0, 1, 2. I have actually used the names. This is the difference which is there from the iris data of sklearn and iris data which I have saved on my computer. So this is the few rows of iris data. Then this is getting features and outcome arrays. So these are the feature arrays and these are outcome arrays. So this is basically the archive of our previous experiences. So the database is nothing but archive of previous experiences. Now this code is to retrieve case similar to our current problem. So for this, I have used the SciPy distance measure. I have used Euclidean distance, and I have used data frame to sort the distances. Then we can reuse a case which has been retrieved. Then we can revise the case and store it, or we can just retain a new case. So this is the application of the codes. So if we have the current problem of, and this is in a vector form. So first feature is 5, second feature is 2, third is 3.5, and then fourth feature is 0.8. So the problem is to which species this feature belong. This is our problem. Now we retrieve case similar to the current problem feature. So we have supplied the problem feature here, and it has the code has calculated the Euclidean distances of the entire previous database, and the shortest distance was 0.2, and it was with case number 60. So this case is very similar to the current problem, and this case solution was the species versicolor. So our solution is versicolor, and this is the feature of the previous similar case, case number 60. So the difference is that in this fourth feature, the value is 1, whereas in our problem it was 0.8. So this is the difference. So it is not exactly matching, but it is very similar. So we can use that species for our current problem with versicolor, or we can so we can retain this, or we can modify the previous instance. So this is the code for modifying the previous stored information. And this is finally to save the updated or trained data to the disk. So this is all for today. Thank you very much.